We ran this webinar series with this group of crop growers because we noticed the value of peer learning and how farmers were learning from each other. A key aspect with this group of farmers is that they've all come together for the same reason. They're all interested in the same types of innovations for their cropping practices. In each of these webinars, we cover a lot of practical information. And to help you navigate the content easily, we've created chapters in the description of the video on YouTube. If you're watching this on our website, first, make sure to click on the YouTube logo in the bottom right corner. And then, click Show More in the description to reveal the chapters. This webinar focused on analysis and interpretation of plant sap tests and featured horticulturalist Mark Tupman from Productive Ecology. Sap testing is an emerging practice where farmers are measuring the sap in plants to understand exactly which foliar applications their plants need at that moment in time. Since the webinar was recorded, we've learned more about how plants partition nutrients. When it comes to looking at the difference between new and old leaves, which is critical for sap testing, there is a principle that where there is more of an element, for example nitrogen, in a young leaf than an old leaf, the plant could use more of that element. This is correct, except when that element is above a particular reference level in the new leaf. In this case, where it's above a desirable level, that element is in excess and the plant has taken on too much. Because sap testing is quite technical, we recommend getting expert advice if you are new to the practice.
Like when we look at this, so we've got obviously, and for those of you that are not experienced with differentials, there's the young and the old leaves, and within that, there's a whole lot of different nuances, which I've got a sheet here I can send to participants. But basically, we've sort of like looked at the nutrient mobility in plants, and some of the nutrients are, I guess what you'd say, highly mobile, and some are less so. And then there's some that are not mobile at all, like silica and calcium and boron, and probably even manganese is not very mobile either. From the work that has been done around the world on this sort of sap testing and just various resources like mineral nutrition and higher plants and stuff, we're looking at how things are really moving, and it's not so cut and dry. Like something like phosphorus, for instance, tends to have one-way movement. So it's a mobile nutrient, but it doesn't easily move back down to mature leaves. Whereas before, we just all thought it was a mobile nutrient and so on and so on. So there's these little nuances, but we've kind of got our head around as many of them as we can. And I'll just refer to them. Like I said, I can send the sheet through to those that are doing sap testing anytime. But when we're looking at these nutrients, as I go through them, the mobility is a big factor. So if we just go through, starting at the top, total sugars, it's kind of total sugars is kind of giving you a good indication of how it's an interesting one because it's not bricks. So we've sort of been trying to figure out what it is exactly, but it kind of gives you an indication of the kind of sugars that you want in your plant, really, not necessarily the sugars that are going to make you more susceptible to insect attack. And also your total sugars are a really good indication of, like, if you're struggling, with certain things like too much nitrogen, and the plants are working really hard to convert that nitrogen into complete proteins, you start to see drops in your total sugars. So like in this case, and this is always the case, you see the younger leaf has a healthier sugar level than the older leaf. And the reason for that is because the younger leaves generally have better, protein conversion, better nutrients available to do all the, processes and all the rest of it. So as always, like the younger leaves tend to show slightly healthier sugar levels. pH is one of those funny things. Again, they say there's an optimum pH that you want plants to be at. In this case, the younger leaves have got a better balance than the older leaves again. And this is what we're seeing is just, plants are always prioritizing their younger leaves, and they're doing what they need to do to balance things out. And a lot of what the sap analysis is about is nutrient interactions rather than just, there's too little of this, we need to add more of it. It's looking at how things are playing off against each other. And the plants are always working to prioritize their fruiting, but also their new growth and then also their, what they send down to their roots and that sort of thing as well. So unfortunately for the old leaves, they're always last on the priority list, and sometimes they suffer because of that. The EC is just the electrical conductivity, and that's a really good one because when you've got really dry conditions, sometimes what can happen is that you've got less water in your plants and you'll get higher readings, like higher reference levels than you'd get if your water levels were good. In this case, the EC is pretty good. Again, more optimum in the younger leaves. But yeah, just giving us a good indication that we haven't got it doesn't, when I look at this one, I don't think that Tom's got an issue with it's too dry, that the plants are actually like short on water. Even though he did say there was a bit of a dry spell, I think it's just looking all right. So everyone's still with me? Yep.
What kind of levels would you be looking at there with the EC mark to indicate water stress?
When they start going off the chart. So when I show you some of David's soon, and I don't know whether that's a result of lack of rainfall or just hard soil or what it is, but there's the EC on some of his both the bars are off the end of the chart basically. Yep. So at any time, just interrupt and ask a question, folks, because it's sort of the nature of Zoom meetings. I sort of can't see if you unless you do because I'm sharing the screen. So potassium is like probably the most mobile of the nutrients, and it's a really easy one because anytime that there's more, there's a demand for it, a greater demand for it in the, you'll have more in the younger leaves. So basically it's, when there's more in the younger leaves, the plants are taking some out of the older leaves and they're prioritizing the younger leaves and they're putting more of the potassium up towards that part of the plant. When there's an excess of potassium, it's the exact opposite. And so the plants will then deposit potassium in their older leaves as just like a storehouse, I guess, for when the time comes that they might need it later in the season, which is normally during fruit fill or grain fill. So in this particular case, there's a slight deficiency in potassium. It's not major because the reference levels are both are reasonable, but you would say the plants are just starting to want a little bit more potassium. Calcium is like the opposite. It's probably the most immobile nutrient in the plants, and it's quite hard to get it out of the soil. And it's probably 95 to 98% of all the SAT tests we've done, there's a calcium deficiency. So without a doubt, calcium is the most widespread plant deficiency that we're seeing out there. And people are doing all sorts of things and have done for years, like putting lime on and, whatever practices you want to try and do to get your calcium up, but we're still seeing calcium deficiency. And that's basically indicating that without really good biological activity to liberate calcium and make it available to the plants, it's going to struggle. And there's also a couple of other key relationships between calcium and potassium and calcium and boron. So if there's too much potassium, which is another thing we see often, it limits the uptake of calcium. And if we don't have enough boron, that also limits it's a synergist for getting calcium up into the plant. So there's a chart that I've also got that I can share with you. And that's this one here, which again, I won't go into in too much detail, but it's a lot to do with the relationships between nutrients. So in the case of calcium, which I was just talking about, if we go to the second row, so we've got calcium, and then we've got these, what we call like synergists. So when calcium is deficient, something that boron and silica are very conducive to helping the uptake of that nutrient. If we've got an excess, boron also regulates calcium. So that was just some of those relationships that matter. And then when I talk about potassium up here, if we go to an excess of potassium antagonizes calcium and magnesium uptake. So there's these different relationships that play out. So normally when we do a SAT test and we get the results, we'll go through and we will tick the deficiencies and the excesses in these columns. Tom, this chart has changed a bit since I last did it with you guys and Terry, because I've brought in another column and I'm trying to make it a bit more understandable because clients were having trouble with it. So you tick your deficiencies and excesses, and then you look at what the synergists are and you check off the boxes. So like if I was deficient in potassium, I would look at the deficiency synergist, which is manganese, and I would tick manganese. So I'd go down, I'd find manganese here and I'd tick the green one where manganese is. And then the same with the excesses, and I'd find the antidotes. So sometimes if we've got too much Potassium, for instance, manganese again is an antidote for that. Or if we've got too much nitrates, there's certain things, nutrients that are related to nitrate conversion into proteins and amino acids. So I would tick those. And then once we've done that, we get this look where we see which boxes have, and we can do one of these maybe if David joins us, we can tick the boxes, and then we get a look at what nutrients might help balance the situation out. And the other thing is they often double reinforce. So what you'll find often is when there's a deficiency, it'll also be playing out in another way where it's, affecting other nutrients. And so you get this thing where you see, okay, we've got a deficiency, but also that nutrient could help with our excess sodium or, our lack of calcium or whatever. So it's a really interesting chart to apply. And this is at the heart of what, is going on in sap analysis and in plant movement and nutrients. It's very rarely a case of, it's not very rarely, but it's rarely a case of just simply, we haven't got enough of that nutrient. It's often related to relationships, and just sometimes tweaking little things can make a huge difference. All right, I'll just close that one up and get back to this.
Hey, Mark.
We're here, by the way.
Oh, David, you're here. Great. So we'll get on to one of yours if you want.
Yeah, sure. Yeah.
Hey, Mark, I was just going to say, most of South Australia believe that we have a lot of calcium in our soils. We soil testing, and we're just off the charts on calcium.
Yep.
So as soon as we started doing sap testing, and all our sap tests were coming back really low in calcium.
Yeah.
So that's where a soil test. It's not lying, it's just not telling you the whole truth.
Yeah.
And then the same as, I know you'll get down to boron in a minute, but, we're finding that we're low in boron until to our boron toxicity layer.
Yeah.
So every agronomist in South Australia worth a crumpet says don't put on boron.
Yeah.
For the first 3 months of the growing season, we are lacking in boron in our saps.
Yeah.
Can we make a couple of comments on that, Tom?
About what, sorry?
A couple of comments on Tom. So certainly we're seeing low calcium levels in the sandy soils, Tom, but on the calcareous soil site at Putra, which would be 70% lime sand, the sap analysis suggests low calcium levels. And at the Soil CRC conference, I spoke to Ehsan Tabakoli and Lucas Answeeten, who are really top soil chemistry scientists, and they're not at all surprised because they're saying the calcium carbonate's just locked up. And as a result, even highly calcareous soils appear to be low in calcium. And Ehsan went as far as to say that he suspects that the yellowing we see in calcareous soils is more to do with calcium deficiency than either iron or manganese. Now, David said he's applying boron.
As with my agro work at Tumby Bay, we've been recoing boron and moly for the last 3 or 4 years, and it's become quite popular. And there's another product called Sugar Mover. I'm not sure who makes that, but that's got those two elements together. So there's definitely a push out there in the marketing business world to apply it.
Just explain to people about that CR ammonia, the ammonium there's off the charts, and then this whole, I know you didn't get there, but just the nitrogen side of it. Now, we do accumulate ammonium in transport, so when we send that away.
Yep.
And then we've got ammonium, then obviously nitrate, nitrate as a nitrate, and then total nitrogen.
Yep.
So can you just run through
those ones
through that and what you want to see?
Yeah. Cool. So we want to get nitrate. What we want is really good protein conversion. And again, this is where it comes down to a couple of key things. It comes down to the form of nitrogen that the plants are uptaking. So sure, they uptake nitrates and ammonium from the soil, but there's also the possibility that some of the microbes can do some of that conversion for you, and through the process of like rhizophagy, which is like plants literally ingesting whole microbes and they're sucking the metabolites out of their cells, they're actually getting complete proteins already, and that's the optimum way for plants to get their protein in a way. But yeah, let's just say they're taking up ammonium and nitrate from the soil. You then need a couple of key things for the conversion to complete proteins to happen, and a lot of that is revolves around certain enzymes, and there's certain enzyme cofactors that are involved. And I know a lot of you know what I'm talking about here, so excuse me if I'm sounding like I'm just repeating information that you know. But what we figured from the SAP analysis, and this again comes back to this nutrient prescription chart, is the enzyme cofactors for nitrate conversion are magnesium, sulfur, and molybdenum. And if you've got good levels of those, you will see zero nitrates 99% of the time in your SAP analysis. So this is what's happening with Tom's here. Obviously, the plants are taking nitrate up from the soil, but even before it hits the leaves, it's getting converted to either ammonium or amino acids or complete proteins. And then we've got the ammonium, which is a little bit harder to convert because it takes a lot of energy, as well as having key nutrients like the magnesium, sulfur, and molybdenum. You also, there's other nutrients involved like manganese and iron, which are the two probably nutrients that we see deficient a lot of the time. You wouldn't think it because they're abundant in the soils, again, like calcium, but for a number of reasons, mostly related to the oxidation state, they're not getting into the plants. So yeah, ammonium conversion is a bit tougher, and we do have this issue where, because we have to send stuff to Nova, and it takes normally about 6 days to get to the lab from the morning you collect the samples. A lot of the proteins convert, in sort of slightly rotting process as it goes overseas, convert back to ammonium. And so we take the ammonium levels with a pinch of salt, but nonetheless, we can sort of see what's going on in terms of like the fact that you've got in your ammonium, you've got higher levels in your older leaves, is indicating that there is actually quite a lot of ammonium, or nitrogen available in your plants, but maybe, we just need slightly better conversion to total nitrogen, because nitrogen is indicating that there's a slight deficiency by the fact that your younger leaves are, they've got high levels, they're asking for more and than your older leaves. So yeah, in a case like this, if I looked at this and I saw these higher levels of ammonium in the older leaves, and then the opposite for total nitrogen, I'd be working more with trying to get your conversion happening than actually applying more nitrogen necessarily, or maybe a bit of both, a combination of both approaches. And part of that would be increasing your photosynthesis to improve the energy production of the plant to do that conversion process. So that would come down to some key minerals for photosynthesis, like like when we're talking, there's another chart I have to show you as well, but basically we're talking about nutrients like manganese and iron and phosphorus for energy movement and that sort of thing, to make your energy more available. But sometimes people also do things like add molasses into the mix and apply that to just give the plants a bit of an energy boost, and that helps with that as well.
With the ammonia conversion process, like what sort of time frame you're talking there?
It should all happen within 24 hours, like within the plant, if everything's really going well. Yeah, so when in Holland, where their samples are close to the lab, if they've got really good conversion, they also get zero ammonia on their results as well, but really good total nitrogen. So, the pressure that you get from things like, sap-sucking insects and spider mites and all that is very much related to your ammonium content in your plants. And so, that, ultimately the end goal for those guys is to work towards zero ammonium in the leaves, but we can't get, I do look at the ammonium levels, and I can show you sap tests with much lower ammonium levels than this. So there is still, even though there is conversion back to ammonium in the transit, there is still probably, ammonium in Tom's plants as it looks at the moment, especially indicated by the fact the older leaves have more. These sort of relationships are really, really key part of interpreting the sap analysis. And
that calcium level there would be a major handbrake on what's going on. You know, Sate talks about calcium being the trucker of all minerals and boron being the steering wheel. So think of that calcium level there is really the massive handbrake that's holding everything else back.
Yeah, I agree, Tom. I think the calcium's a big issue here, and I think the magnesium's a big issue as well, because the magnesium, when magnesium is interesting because it's a mobile nutrient, and even though you would think because it's mobile, obviously it's you know, it's gonna move between young and old. But what we find with magnesium is that once it gets into the old leaves, it gets stuck in there. And to be honest, most of the sap tests I do, unless there's an extreme magnesium deficiency, you'll always find it higher in the older leaves. And this is one of the first things that jumped out when I saw these results, was that magnesium was higher in the younger leaves, which means it's actually an extreme magnesium deficiency. The plants are really wanting more magnesium. And yeah, the calcium obviously is really low. And then also potassium in this case, you know, they're really wanting more potassium. So those three are like major limiting factors, whereas the nitrogen, even though it's low in total nitrogen, your ammonium levels again are reasonable. And I would say if you can get your magnesium levels right and your calcium and potassium, I think these plants would change dramatically in how they worked. And I think your nitrogen conversion would improve and all of that sort of stuff. So yeah, you know, I think, you know, sure, you could apply some nitrogen as well in the mix, but yeah, like you say, and it would be interesting to do the like we could do one of these. Do you want to do one of these for this particular sap analysis? Does that work with everyone? Might as well, hey?
Hey, Mark, can I just ask a quick question?
Yep.
So you're seeing there on the sap, you know, you're saying that the higher reading in the newer leaf versus the older leaf is wanting, that's, you know, that plant is uptaking more of that nutrient because it wants it. Does that work for all? It's
not really uptaking more of it. It's more just partitioning more of it to the younger leaf. So what its supply is limited by the xylem flow.
Yeah.
But it will then, via the phloem, it will then, if it's a mobile nutrient, it will partition it toward prioritizing the younger leaves, or the if it's got too much, it'll deposit it in the older leaves as like a bit of a stockpile for later in the season. So yeah, it's kind of the opposite with the very immobile nutrients like calcium, normally, or boron. Normally what happens is, you know, like your xylem flow, because they're not moved around the plant, you'll often see them higher in the older leaves, but because they sort of accumulate in the older leaves over time. But yeah, and this
what's it? Well, I was just looking like what's his. Just scroll down for me, like his zinc levels there.
Yep.
Yeah, both off pretty well off the charts, but but looking there, yeah, 8.9 versus 6.9. Yeah.
Yep. Yeah, I mean, zinc's one of those nutrients that's not that mobile, so it's kind of hard to like. It's kind of hard to sort of say use the differentials on that, but definitely the levels are very high, and that's going to have an impact on different relationships. Yes. And you know, this one particularly is very low in iron and manganese, or it's low in iron and manganese, so that's going to affect photosynthesis. It's really low in phosphorus, or it's really demanding more phosphorus. Like the old leaf phosphorus is really, really low. So that's, you know, that's actually another limiting factor with this one. So I don't know, David, you could probably tell us, but I would predict that this Ranford crop doesn't look great, this Nil, from this sap analysis.
No, the Nil looks very ordinary.
Yeah.
I'm sort of expecting that to go perhaps 1.5 tonne, even though rainfall's been quite good, although June and July were down in totals, but it's not, if I dug down 30 centimetres in this soil, I'd find the sand wet. But the question, I guess, is that if we look at phosphorus, we did talk quickly about phosphorus. the young leaf has got very high phosphorus levels, extremely high, and the old leaf's got very low phosphorus levels.
Yep.
Now, how much does the high level of the young leaf offset the low level of the old leaf?
Even though it looks like the young leaf is high, I'd say because of the EC that this is not necessarily a high reading of phosphorus. And when I do phosphorus, it's a one-way movement. It's got one-way mobility in the plant. So I'll just bring this one back up again just to show you guys, and I'll send this to you, like I say. But with phosphorus, I don't know if you can see that, but it says, due to its ease of movement from mature to young leaves, but less so from younger leaves to mature leaves, phosphorus is often found higher in the younger leaves. So we almost always see it higher in the younger leaves. Higher levels in the older leaves are indicative of an oversupply, which is quite rare. Reference levels in mature leaves are a better indication of P status. So because of this one-way movement, I tend to look to the mature leaves for my P status more than the younger leaves. But the fact also that there's such a discrepancy in levels between the young and the old is indicating the plants are calling for phosphorus, like really, really, really needing more phosphorus in their younger leaves. And that's, again, either due to a issue of, again, like you can see the younger leaves are higher levels of everything, and it's needing phosphorus, for all the reactions that are going on with all these other nutrients and, the molecules that are getting made and the enzymes and everything. They're obviously needing phosphorus as well, but the supply is so limited that the plants are taking all they can out of the old leaves and putting it into the young leaves. So I would say that there's definitely an issue with phosphorus here, like without a doubt. And this is the problem with doing just young leaves as a sample, because when you send young leaves to a lab and you get that result back, you think, geez, my phosphorus levels are awesome. But actually it's the older leaves that are much more relevant when it comes to phosphorus.
I'll just make a comment there, Mark.
Yep.
I know Ben pretty well, and he has cut back on his phosphorus inputs. He's gone down a more holistic path with his microbiology and foliar applied elements. So it's interesting that that's showing up there.
Yeah.
In that sort of way.
Sometimes too, what we get with phosphorus is when people put it on like DAP or MAP, especially at planting, the plants have good availability of phosphorus for a little while and they take up what they can, but it can interfere with the development of strong mycorrhizal networks. And because, like basically the mycorrhizae doesn't really colonize the plants well if there's too much phosphorus already, soluble phosphorus in the root zone. And so then what will happen is the plants will take up quite a lot of phosphorus, and we'll see good levels of phosphorus early on in the season. And then as the season goes on and the phosphorus locks up, and then there's a lack of mycorrhizal colonization, we start to see the plants run short on phosphorus later in the season when it's really important. So that can be a factor. And this looks like there was a reasonable amount of phosphorus in the plants maybe at some stage when they were young, but now they're starting to take all the reserves they've got because they're running short on their supply from the xylem, and they're using all the stuff in the old leaves in the young leaves. So that's another factor. Then it's something that we see often is that the seed, when phosphorus is applied with in furrow, it can cause problems later in the season.
While we're talking about phosphorus, Dion Trizonis here, and historically in their area, phosphorus.
Do you want me to go to Trizonis?
Yes.
There, David?
Yeah, that would be good. Phosphorus has been one of their major limitations. So when we get it up, I'd actually ask Dion just to comment.
Which one do you guys want to go? Which one do you guys want to look at? Out of
we'll go through it. So this one here is actually one of his better performing treatments.
Yep.
Because what we did is we loaded the manure with phos acid.
Yep.
So that was one of his better ones. The mule is standard treatment.
And there's not a lot of difference between the two, Dave. Like between the nil and the basal manure P, there's not a lot of difference in the phosphorus levels between the two.
Yes.
Yeah, you're right.
So they're bloody near identical phosphorus. So the amount of phosphorus that we put in the dirt, like with the phosphoric acid plus the manure, considering the other bit's only got 25 kilos of fertilizer on it, the phosphorus levels haven't actually changed.
Yep.
Between the two treatments.
But there's a clear visual difference in plant growth. That's right, isn't it, Dion?
Yeah, there is.
Yeah, there might be a visual difference in plant growth between what's the one that's showing better?
Well, the one with phosphorus and manure added is
Okay,
better.
let's
than
go to
the
that. So that one
and
there.
the ripping treatments are better again.
Yeah.
Yeah, the ripping treatments. So like we kind of have to discount the ripping treatments because, as you said, there's issues with compaction and water entering the soil. And I think as soon as you're ripping, you're straight away getting a result. So we can almost conclusively say, regardless of the sap, you know, that's sort of separate to what the nutrient levels are, and it's a big factor. But between these two, which wasn't ripped, so this one, does this one look a lot better than the nil, the basil, the basil and manure and pea?
Yeah.
It does.
Yes.
Okay.
But at the same time, Mark, it probably doesn't look. If you had to work out the dollars and cents value of it, it wouldn't be paying for itself better.
Yeah, yeah. It doesn't look much different on the sap to me in terms of, like, if I looked at them both, just to have a quick look through them all, I wouldn't say that.
I think the main one, the difference between the two is the molly.
Yeah. You've obviously got a deficiency.
As far as look at them side by side on a chart, they are identical.
Yeah, yeah. And this is again another thing that we see all the time, is that people put on soil treatments or nutrients in the soil, and it doesn't always change things in the plant. Like, whereas, and you know, Robert will testify to this, if we do a foliar that's formulated right, especially of trace elements, you can get your nutrient levels in your plants to change radically. Like, they can double or, you know, triple or whatever you want them to do. Whereas sometimes putting, you know, stuff on the soil, we just don't see, especially things like phosphorus, because it locks up so quick. And, you know, we might see an initial hit where it jumps up a bit, but then it'll pretty soon stabilize. And same with things like manganese and iron and that. You can put it on the soil all you want, but it just doesn't shift things at all because of the oxidation factor.
Now, Mark, just out of curiosity, why is it that one of them's got nitrate, the N3 and the N nitrate, and the other one's got none?
Yeah, so that's an indicator, and it's in the young leaves. So what we're looking for is a deficiency maybe in magnesium or sulfur, moly. Let's have a look at the other one quickly. Yeah, it's interesting, that one. I'm not sure.
They're nearly identical, and yet one of them's got nitrate and the other one doesn't.
Yeah, it's interesting. I'm not quite sure why that is. Let me just have a look at the iron and manganese. Yeah, I don't know why that is. I mean, I'm looking at the key nutrients that are needed for conversion, and I'm not seeing why that has got that hit of that nitrogen. Sometimes, I mean, when you're looking at it though, we're looking at very low levels of nitrogen, nitrate, I mean. So sometimes you might just have like a thing where, I don't know, just a little bit of nitrate comes up in the xylem and, you know, it's not converted, and you see that. It's like this amount of nitrate in just a young leaf, I'd say it's not a major concern, and you might find that will, you know, if you did another sap test on that same crop on, you know, a week later, it might not be there.
But
I can't say
it is interesting that the nitrates in the poorer performing treatment.
Yeah.
And this is why I come back to how important is this dilution effect.
Well, what's the indication of water stress in the two? Are they the same?
Let's see. So EC, we've got, so you see we've got a lower concentration of nutrients in the younger leaves. Let's just go between the two, just make sure I've got both of them there. And just get this one up. EC, yeah, they're pretty much the same, really. There is slightly, it looks to me like it's slightly drier than nil treatment, or, you know, slightly less, there's less water happening in that. So we've got 23 and 18 as opposed to 26 and 17. Yeah, no, it's really hard to say what's going on there, folks. I'm sorry.
One thing we saw on Dion's data, plus Dion Williams, plus the Calcareous Soil Project data, is that we've got these high EC levels, but I think that there still might be a dilution effect happening. It's just that if the salt increases at depth in these soils, so I'm wondering if, well, yes, we might have a dilution effect because we've got a better growing plant, that might be offset because the plant roots are going deeper and accessing more salt.
Yep.
That's just a thought.
Yeah, the sodium levels is not high though in these. Is that related to it, David, or is that a different sort of?
Well,
kind of follow your thread.
Well, if you have a look at the EC and sodium, but look at the chloride. So the chloride is indicating that we are accessing sodium chloride.
Yeah.
And that increases at depth in these soils.
But I have to tell you, like someone like Robbo's is a lot higher. And I actually see sodium a lot higher a lot of the time than what I'm seeing on Dion's here.
Yeah, but hang on, we've got two sources of sodium here.
Okay, yep.
Exchangeable sodium,
yep.
which a lot of the mid-north guys, they've got a lot of exchangeable sodium in their soil, as has David Foster. But for a lot of other guys like Dion Trezona and Dion Williams, it's not exchangeable sodium, it's sodium chloride.
Yep.
So I'm actually wondering whether, when we talk about sodium in the SAP analysis, are we talking about a combination of exchangeable sodium and sodium chloride? In other words, different sources?
Yeah, I'm not sure.
My chloride's off the charts in Olive.
So you must have sodium chloride there as well, Tom.
Correct. We're only 60 k's from the water.
Yeah, most of the Australian samples I do have quite high chlorides and sodium.
If you want to see some of the charts, you go to Jenny Stanton's on KI.
Yeah.
They are extremely off the charts.
Yeah. And we're the same here in Margaret River because we're near the coast.
Look, there's just under half an hour of our time left.
Yep.
And I would like to make sure that people are asking questions. I wonder if anybody who hasn't asked a question has got something that they want to ask about things that we've been talking about, any of the particular pieces of data or concepts, ideas that we've been talking about. Anybody else?
Hey guys, sorry I couldn't find the raise hand button. Yeah, I'm new to agriculture and just studying Regen Ag online, so this is all pretty new to me, so it might be a dumb question, but when you look at those EC levels and if they're off the charts, so is that throwing out all of your other minerals there, or?
No, it's more just an indication that there's a higher concentration of nutrients in the plant, which again is probably most likely due to a slight lack of water.
Okay, so you're still getting a reasonable reading, even if you've got a high EC.
Yep.
All right, cool. Cheers.
Yep. I mean, the high EC, actually, normally what happens is just you'll see your overall nutrient levels will be higher. The reference levels will be higher. So, like, this one looks like, you've got quite high nitrogen, but it's not really because the EC levels, there's probably just a higher concentration of nitrogen in the sap because of the slight lack of water.
Okay.
So yeah, if anything, you just sort of start to, you sort of go, okay, maybe I should just underestimate those reference levels a little bit because the EC is high. It's not so bad here as some of the other ones. I mean, your young leaves are not showing it so much, so yeah.
Yeah, cool. And sorry, one more.
Yeah.
In my course, there's a lot of talk about the soil biology, and it's interesting looking at that excesses and deficiencies chart, which is pretty cool. How does that, if you're correcting these mineral deficiencies and excesses, where does that tie in with sort of improving soil biology and getting that soil food web in balance, if that's a real thing?
It's kind of like, I'll just bring up one other chart for you that I think the key with the nutrients is understanding what they all do. And the thing with the nutrients is that, like they're related, what they do is related to certain plant functions. And of course, the big one there would be photosynthesis. So if you get the right nutrients needed for your plants to photosynthesize efficiently, then they're going to be sending a lot more, they're going to have a lot more carbohydrates to send to the roots and to the soil microbes. And so a big part of this is applying the right nutrients to kick in photosynthesis and also efficient protein conversion, because that's also a very costly and energetic sort of affair. it's all about, you know, economics of how plants use their energy, and, you know, so yeah, if we can get the nutrient relationships right, and the, you know, the things that are missing in there, then things like photosynthesis. So in this case, like photosynthesis, we're looking at magnesium, nitrogen, obviously they're all part of the chlorophyll molecule, and then where phosphorus is for energy transfer and all that sort of stuff. And then iron and manganese. Iron is also a very important part of chlorophyll, and manganese for water hydrolysis, like splitting water as part of the photosynthesis reaction. So all those nutrients need to be good, and we often find that if a couple of those are deficient, we can, you know, we can apply them as a foliar, and then we can boost our photosynthesis, and then that makes energy available for protein synthesis, but it also feeds the microbes in the soil better, and you get better, you know, just delivery of other nutrients because of that. So it's kind of a, like, this is like a biological sort of, you know, I just guess like a kickstart is, it's like everything's tied together. The biology obviously feeds the plants, but then, you know, the nutrition also enables the plants to perform better to feed the biology. So yeah, it goes both ways.
So going by that chart there, Mark.
Yep.
With the manganese and iron, if it's like, you know, is that just promoting the photosynthesis, or as it's photosynthesizing, it's using the nutrient?
In the case of iron, it you know, like it's part of chlorophyll, so it is using the nutrient. But, you know, like it's not something that gets used and then used up when it's creating sugar. It's you know, it's there. It's just as the plant grows, it needs more of it. And it's pretty much the same with manganese. It's used for an enzyme. It's like an enzyme cofactor for the enzyme that splits water. So again, you know, the plants don't use it up in the photosynthesis reaction, but they do need more supply as they're growing and you know, making new leaves and all the rest of it. So yeah,
that's like, if I'm correct in my understanding, Mark, that iron is actually part of the solar panel.
Yep.
You know, the chlorophyll.
Yep.
And the manganese is a kind of a fuel that's used but recycled in the process. The plant keeps using it and recycling it and using it again. But
yeah,
the more solar panels you have, the more fuel you need to make the solar panels go, that you can keep recycling. Is that correct?
Yeah, basically, yeah. I mean, often with the traces, a lot of the traces are not directly related to, you know, structural materials or proteins, or they are to some degree, but a lot of them are also just enzyme cofactors, which means you only need small amounts of them to make the enzymes. But still, as the plants are growing and developing, you still need a critical mass in all the different, you know, parts of the plant.
Hey, Graham Martin speaking. I have a question.
Yep.
What about the forgotten mineral like silica, as far as being basically a crop protection product against the elements?
Yep.
And also, if the plant's more resilient to stresses and things, that better able to utilise some of the minerals that are available.
Yeah, I mean, silicon's really important. And when we don't have good, again, it's like calcium, it's fairly unavailable, you know, in the soil. And again, you've got to have good biological activity to make it available. It's actually like just a real good indication of how your biology is. And like in this case, just looking at Dion's, it's actually not so bad. Your silica looks all right. Let's just have a look at a couple more.
Most of the levels are fairly high, I think.
Yeah, you often find too with the cereals, the silica, I find with the cereals, the silica is pretty good. Grasses have this unique ability to extract silica from the soil. There's actually a whole back history of that. So all of these are cereals, whereas if I showed you another crop from my sap analysis that wasn't a grass, you'd find that often the silica levels are not nearly as good.
Yeah, I actually applied high rate of silica out on some beans, hoping to get some better results in a frost-prone area and everything else.
Yep.
It's against other crop protection products, that's all.
Yep. Yeah.
Anyway, it's just a question that's got a wide open door, isn't
it? Yeah, no, it's a really important factor. And if I see silica problems in the plant from the sap, we definitely want to try and address, you know, like biology and boost it up using a combination of stimulants and foods and just good practices to try and improve the silica levels. And especially plants like with weak root systems, like there's certain types of plants that really struggle. Like if we've got cucurbits, like cucumbers and stuff, and the silica levels are low, it's a real issue.
Yeah.
Do you also see that with sulphur as well, Mark? Disease susceptibility, low sulphur?
I'm not 100% sure, but I think so, in the sense that, I mean, sulphur is part of, a lot of the different, protection compounds, all the different secondary metabolites, and also it's an important part of amino acids, and it's also an important part of protein conversion. So yeah, I think low sulphur is an issue for sure. It's not something we see low a lot of the time, but occasionally we'll see something that's low in sulphur. And also, obviously every time you're applying sulfates, you're getting a hit of sulphur as well. So yep.
Yeah, another question. I guess in terms of trying to get farmers to adopt this new method of thinking about how to grow plants, and how does this, what's the draw card for farmers if they're, in terms of profitability, if they're improving all these factors and getting a healthier plant? Are we seeing higher yields, higher profitability, or how does that tie in with sort of more conventional practices going on, if that makes sense?
It's exactly why we're doing it, Nick. we want to reduce our inputs. We want to target our inputs so that we really are getting a good, healthy nutritional profile happening in the plants, so that they are, we're using less inputs, so less money involved. As we know, inputs are pretty expensive, and also being very efficient with how we deliver them to the plant. So this is where the foliars come in. And then finally, when you get them right, the fact that the plants become very efficient, they feed the biology really well, they become, they've got good protein conversion, so they become resistant to a lot of the pest and disease issues. And then finally, when you get to the point of fruit fill, having those key relationships, like tracking things like potassium and calcium, that relationship is really integral to getting like good, strong, healthy fruit fill. And also, again, of course, protein conversion, which means, you get high protein levels and all that sort of stuff. So yeah, that's exactly why we're doing it, is to pretty much lower costs but improve quality. Yep.
I think we're learning too. Like my family's put a lot of phosphorus out over the years, and really, my phosphorus levels should be off the charts all the time with the amount of phosphorus that's been put out and money spent. But we're just not seeing that as soon as we go to SAPs. Where we're seeing the advantage there is we've taken our phosphorus budget away, and we're putting out a little bit of, micronized guano out as a foliar and lifting phosphorus levels that way. So, it's more of a targeted approach where you're spending your dollars.
Yeah, I'd like to support what Mark was saying there before. I think one of the really important points is with balanced nutrition, fine tuning during the growing season with these SAP tests is the resilience of the plant. And we've experienced that quite a bit, to the point where we've actually had farmers not have to use fungicides and insecticides at all. And in one particular year, when there was a very bad stripe rust year, so the stripe rust was still there, but it didn't take off like it did in traditional crops. So yeah, this and that's does a lot in the health of the soil when you're not using insecticides or fungicides, or reducing the use of them, for the biology in the soil to really function much more actively.
Yeah. Yeah, I work with both, like biological and conventional farmers. And I think, the thing that I don't think SAP analysis is like, it's not everything, and it's not perfect, but it's as good a system as I've been able to find to correlate the plant health with a tool that we can actually measure and tweak. And what we've found is just, like I'll go to farms that are just using heaps of, DAP and MAP and, various things like, urea and that sort of stuff. And, not necessarily wrongly. I mean, sometimes, it's the right thing for the situation, but then we'll do a SAP test. It's because their plants are not looking great. And, something like calcium will just be like so low, and manganese and iron will be super low. And, like the limiting factors that we're finding really enlightening. And when we address those, like the difference in the crops is, it's just really, it's really, it's just really rewarding to see. And it sometimes can be treated, with quite simple sort of foliar sort of applications and things. Calcium is the trickiest one we're struggling with, to get calcium, because you need a lot of it and you need it to come from the soil. It's quite hard to put enough out as a foliar in the right form, but everything else we're finding we can. Phosphorus is also a bit challenging, calcium and phosphorus, but everything else we're not having any trouble at all changing the levels and tweaking and that sort of stuff. So yeah, I'm converted myself. It's a great little, it's working really well for us. And I do a lot of different crops, a lot of different types of everything from cereals through to horticulture, through to a lot of orchards as well. And we're having great results with it.
Mark, maybe now's a good time to go into that chart, that exercise that you were talking about.
Is there one, David, that you want to do in particular out of all of these?
Well, I was going to ask everybody there, do you want to look at a sand, a calcareous soil, or a heavier sodic soil? Because, they're all a bit different. Any views about which soil type you'd like to look at?
I'm always interested in those calcareous soils, but depends on what everybody else is thinking.
Yes, I go along with that, Dave.
Yeah, you would. But yeah, look, we could do that, or do we want to show
which one of those would be, which one would that be, David, the calcareous soils?
Well, you're looking at Diontrozonas and the two that we've already got up. But they're not showing much difference, I guess. That's the only downside.
Not much difference between each other.
Yeah.
Yeah, but I mean, that's often the case, you see. So like, it's because he's growing them in similar soils and soil sort of oxidation conditions, regardless of the nutrient applications, probably only the rip's going to make much difference in terms of that sort of stuff. Regardless of the nutrient applications, you're not going to get much difference sometimes. And we're seeing this across the board. Farmers are doing all sorts of different applications, but a lot of it's coming down to really basic things like the soil function in terms of water and aggregation and oxidation states, and then that's really like playing out, and regardless of what they're doing nutrient wise sometimes, or putting on the soil in terms of nutrients, it's still not really changing the sap levels. But then when we do foliars, we do get lots of shifts, not just of the nutrients we apply, but also the other nutrients that are related because of the nutrient interactions. So yeah, despite the fact that Dions are not much difference between the treatments, they will still give us a really good indication of what its limiting factors are in this environment.
Okay, go for it then. Yep.
So anyone in particular, Dion?
Oh, Foster with his chocolate dirt.
Sorry, what was that?
Like that is probably looking ridiculously good, and it'd be twice the crop as mine.
Yeah.
And yet when you come back to a nutrient level, that's not a lot of different.
So which one was twice the crop of yours?
Oh, that'd have to be like Foster's down there with Dave Davenport.
Oh,
the
yeah,
with the
legume. Yeah. So yeah,
his crop's probably going to go somewhere between 6 and 7 ton probably.
So you're saying his nutrient levels are not much different in terms of his soil or in terms of his sap analysis, or?
Well, yeah, just the sap analysis side of it.
Okay, so let's look.
If you're going to try a grey calcareous dirt to a really good, healthy dirt that you could almost put in a mud cake.
Yep.
And the plant growth that you get out of the pair of them, somewhere along the line, I'm trying to get my plants to be as healthy as what grows in that dirt.
Yeah.
So it's not about nutrition then, is it, Dion?
Well, somewhere along the line.
What's the difference between your soil and David Foster's? Biology?
Well, the
function.
You could
function.
Go into a chocolate bar. But his dirt's that good that you could almost eat it.
Yeah.
Mine's a sand.
Yep.
I can't work out, like when you come back to a plant nutrient level.
Yeah.
I can't work out why my crop is not doing 7 to 8 ton like his.
Okay, let's just have a quick look at his, just out of interest. Yeah.
Sounds like what you're saying, Dion, is the sap levels are indicating similar between the two crops, but obviously they're different because the geologies of the soils are different and the crops look quite different. We know one is going to yield much more than the other. Is that what you're saying, Dion?
Probably. Like his phosphorus levels, the iron, manganese, all through there, there's not a lot of difference. Even the phosphorus levels. Fair enough, his new leaf has got more phosphorus.
Yep.
But his old leaf phosphorus is not much different.
Yep.
And I can't.
Yep. Okay, I'm hearing what you're saying. I'm just having a quick look just to see if I can see anything jumping out at me between the two.
Like ideally, that's my goal, is to try and get my dirt to produce crops that you see that people are growing down the road on a different, on a heavier, or not a heavy, it's a heavier dirt, but it's also a more biologically functioning dirt because it's always got a bit more organic matter in it and it's always got a bit more stuff in it.
Yep. Yep.
And when it comes down to actually what the plant's growing, there's nothing. I thought, maybe my phosphorus should be like right back, barely registering on the back left corner or something.
Yep.
But everything seems reasonably even or consistent across the whole lot. Even Benny Ranford's is not that much different.
Yep.
For some reason, we're growing half the crop.
Basically, the temperature of the soil.
Yeah, it sounds to me like it does sound like it's a function or a temperature or a rainfall thing as opposed to nutrient thing, because you're right, his nutrient levels don't look any better than yours.
One comment again, Mark, is that the biomass at David's when I took these would have been double that of Dion's when I took those at Dion's.
Yep.
At least double. And the other thing is that Dion's soil is heavily oxidized and will continue to be heavily oxidized. And its labile carbon is much lower than say
I mean there you go. I mean that's a huge factor. One thing I have noticed, I'm just looking at Dion the Foster one now, and just because you mentioned the oxidized soil, I jumped straight to iron and manganese. If you look at his iron and manganese levels here, we've got, let's just remember these, we've got 3.81 of iron and 10.28 in the new leaves, right? Now I'm just going to flick back to Dion's. Okay, so we've got 2.37 and 5.21. So we've definitely got slightly lower levels just because of the oxidation factor. However, your older leaves are better, Dion. So I don't know. It's a tricky one. But yeah, it's all I can say. Yeah, I mean, I don't know the ins and outs of it, guys. But to be honest, it sounds like it's not it's less of a nutrient thing in this particular case and more of a something to do with soil function, penetration of roots, water, temperature, one of those factors. But I don't know much more than that. Sorry.
It's just one more question. What do you think about seed coatings?
Yeah, I mean, seed coatings and biostimulants, all in the aid of setting up a strong microbe plant biome from the beginning, goes a long way for, towards helping with calcium and phosphorus uptake and, aggregation and all sorts of things. So big, like what we're moving towards a lot nowadays, just to try and deal with the fact that calcium is so hard to get into the plants, is using, some sort of, we're following AEA's example on this and just using as much as we can, some sort of soil priming and also, inoculation or stimulant sort of packages. So whether you're putting on, a combination of molasses and fish and sort of compost extract, that sort of stuff, initially to kind of give the biology a bit of a hit, but then also maybe putting compost extract in furrow or coating the seeds, and then also doing foliars with, when the plants are very young, with stimulants, again, that, stimulate photosynthesis from a very young age, as well as just tweaking the nutrient levels. Like if we can get the nutrient levels right from the very beginning, then, you know, that means the plants are going to be photosynthesizing well and converting proteins well. And that all goes a long way towards setting up a strong soil microbe system. So those initial treatments that stimulate biology, but also just tweak the nutrients in the cropping cycle is really, really important. And then, you know, obviously when they get to fruit fill, that's another really important time because they need specific nutrients for reproductive phases.
Just on a side note there, Mark, when you start talking about stimulating stuff early on, how do you, what part of the stimulation that you're putting on is solely uptaken through the leaf, and how much of it is actually wasted when it hits the dirt? Because I actually have a lot of trouble growing enough canopy. If I went out and tried to put a foliar trace element on, not having enough leaf there to be able to actually get it into the plant.
That's you know, obviously a fair bit of it goes on the dirt, Dion, but a lot of it comes down to how you formulate your foliars too. So we've had a couple of major issues that we've ironed out, and Tom knows all about this because we've talked a lot about it, and maybe Terry knows a fair bit about it too. But one of the issues we've had is that people are making up foliar sprays and they're not getting the pH right on their tank, and they're suffering from bicarbonate reactions that are causing unavailability of the sulfates that they're putting in. And that's a major one. So getting your tank pH right before you add, and then getting your nutrients into the right form and chelated before you add them to your tank, pH adjusted. And then, you know, including things like fulvic acid and all that sort of stuff. So people are using various agents for reducing chelation, like citric and fulvic and glycine, that sort of stuff. But those factors are really important, and we're finding that you put out a foliar, and if you get it right, the sap levels are moving really quickly. However, that said, because some of it's going on the soil, normally I'm trying to just, you know, put as much into a pass as possible. So we're doing up a mix where we will have, you know, like our chelated nutrients in one sort of one vessel, and then we will get the tank pH right with citric acid. Then we'll add the chelated nutrients, and then we'll also add compost extract, and then we'll also add, you know, biostimulants like molasses or fish, sometimes seaweed, and then that combination, you know, like obviously the traces, you're hoping that they're going to go in through the leaf, but all the rest of the stuff, it has a stimulating effect on the leaf, but it also actually is a really good soil primer. So, you know, the molasses and the fish and the compost extract going onto the soil is not a bad thing at all. Obviously, you want to do it in conditions where it's not hot and dry, or there's a little bit of moisture around, but yeah, all of that helps. So yeah, I mean, I can't give you an exact one, and I know it's a bit of a struggle, but sometimes when the plants are really small, but you know, if you can, yeah. I don't know, Robbo, you can maybe talk to that a little bit more. I don't know if what your thoughts on that are.
I mean, even if you get 1 or 2 drops on a small plant, that's still a fair bit for that size plant.
Yeah.
So it all sort of works out in the end, you know. So
that's right.
1 or 2 spray drops on a 2-leaf wheat plant, you know, is a big kick in the gut, you know, compared to, you know, 2 of those same drops on a plant that's at 31. So, right, you know, in forms of the ratio like that, I think what Mark's talking about is getting your tank pH right and sorting out a lot of problems with our spray water is more critical than a lot of other things that, you know, has been chatted about.
Yep.
Because we both a bloke we both know, Mark, you know, he's a farmer from down Mount Gambier way, couldn't lift his manganese. They were pouring out heaps and heaps of manganese. And then as soon as he went to Mark's recipe of acidifying the water before the traces went into it, the next sap test he did, he had beautiful manganese levels.
Yep. Yeah, I have to be honest with you, when we first started sap testing, the first season, spent ages trying to tweak chelation and reduction recipes for manganese and iron, and kept on putting it out, did a whole season, and it wasn't really moving the sap result, the sap levels, and I was kind of bashing my head against the wall. And then finally, when we, you know, the sort of few different webinars about adjusting the pH. There's one by Joel Williams and also another one by AEA, David Miller. And then I did it. And then very next SAT test, like they just jumped through the roof, and I was like, oh, there it is. So now, you know, we're less worried about all the other stuff, and we just make sure that we get the, you know, get the pH right in the tank before we add the chelated nutrients or the, you know, to it, and it's making all the difference.
Thanks very much to all of our speakers and webinar participants. So much learning comes from the group interaction with questions and answers. Thanks also to the Australian Government's Future Drought Fund for supporting this webinar series. You can find more resources about this and other webinars in the description of this video below. We would love to run more of these events, and if you would like to become part of our growing farmer community, join our social media pages and subscribe to our newsletter to hear about the next opportunity.